Hello everyone, this is Shran from LearnAccount with another video on fundamentals of industrial automation. In this video series, our goal is to explain the key concepts of automation using short and simple terms. Today we talk about variable frequency drives or VFDs. VFDs are essential in the world of motion control. In this video, we break down the key components, how they work, the benefits, and some real-world applications. Let's dive in. Have you ever wondered how the speed of a motor is controlled? One common way is with a device called VFD or variable frequency drive. A VFD basically controls the speed of an AC motor. It does this by adjusting the frequency of the electrical power supplied to the motor. Think of it like a dimmer switch for a light, but instead of controlling brightness, it controls the motor's speed. Let's take a closer look at the key components of a VFD. The rectifier is the first stage of a VFD. It takes the incoming AC power from the main supply and converts it into DC power. This process is achieved using diodes, which allow current to flow only in one direction. Next is the DC bus, often consisting of capacitors storing and stabilizing the DC power. It smooths out any fluctuation in the DC voltage, ensuring a consistent and stable power supply for the inverter. This stage is crucial for maintaining the quality and reliability of the VFD's output. The inverter is the final stage of a VFD. It takes the stabilized DC power from the DC bus and converts it back into AC power with variable frequency and voltage. This is achieved using insulated gate bipolar transistors or IGBTs. So how does a VFD work its magic? First, the VFD takes the incoming AC power from the electrical grid and converts it into DC power. Then, the clever part, it converts that DC power back into AC power, but at a variable frequency. This change in frequency is what allows us to control the motor's speed. A lower frequency means a lower motor speed, and a higher frequency means a faster speed. Now, why would you want to use a VFD? One of the biggest reasons is energy savings. VFDs save energy by matching the motor speed to the actual demand of the application. For example, if a pump doesn't need to run at a full speed to meet the demand for the water, the VFD can slow it down, reducing the energy consumption. This avoids wasting energy when a motor runs at a full speed unnecessarily, and lower energy use translates directly to lower operating costs. The other advantage is increasing efficiency. Let's use a simple analogy to make this even clearer. Think of your car's gas pedal. It controls the engine's speed. A VFD is like a gas pedal for a motor, giving you precise control over its speed. Just like you don't always drive your car at full speed, motors don't always need to run at full speed either. And because they reduce the stress on the motor, they can also increase the lifespan of the equipment itself. Now let's look at some real-world applications. VFDs are used widely in HVAC systems. That's your heating, ventilation, and air conditioning. In these systems, fans and pumps are often used to circulate air and water. Traditionally, these fans and pumps would run at full speed at all time, even when heating or cooling demands are low. This wastes a lot of energy. By using VFDs, the speed of these motors can be adjusted to match the actual heating or cooling needs. On a mild day, for example, the VFD can slow down the fan, reducing energy consumption and making the environment more comfortable. This leads to significant energy saving, lower operating costs, and more efficient and responsive HVAC system. Next is conveyors. Think about a conveyor belt in a factory or a distribution center. Often, the speed of that conveyor needs to change depending on the number of products being moved or the specific stage of the process. A VFD is perfect for this. Instead of running the conveyor at full speed all the time, a VFD allows you to adjust the speed precisely. If fewer items are being transported, the VFD can slow down the conveyor, saving energy and reducing wear and tear on the belt and the motor. And when things ramp up, the VFD can smoothly increase the speed to keep everything flowing efficiently. This precise speed control is essential for optimizing throughput and minimizing motor damage. Now let's consider elevators. Smooth acceleration and deceleration are crucial for passenger comfort. No one wants to be jerked around every time an elevator starts or stops. VFDs provide the smooth control. They allow the elevator motor to accelerate and decelerate gently, making for a much more pleasant ride. Beyond comfort, VFDs also improve the leveling accuracy of the elevator, ensuring it stops precisely at the correct floor. And, just like with conveyors, VFDs save energy in elevators by optimizing the motor's performance based on the load and travel distance. Okay, that was our summary about the VFDs or variable frequency drives. I hope you learned something new. If you found it helpful, please make sure to subscribe to the channel and share the content. Thanks for watching and see you next time.